Welcome back to Maths in an Empty Classroom with me, Mr. Southern. This is part 3 of the lesson on friction, and in this video I'm going to be explaining how to find a coefficient of friction. Okay, here we have the scenario. A package of mass 12 kilograms is pulled along a rough horizontal floor by a light inextensible string inclined at 20 degrees to the horizontal. If the package accelerates horizontally along the floor at a constant rate of 2 meters per second, and the tension in the string is 50 newtons, find the coefficient of friction between the package and the floor. Right, okay, so first off, we have that it's a rough horizontal floor, implying that there's going to be some friction that we're going to have to find. And what we have also is a light inextensible string inclined at 20 degrees to the horizontal. So let's draw that on to start with. There's my light inextensible string. And that has a tension of 50 newtons. So I'm going to label this force with 50 newtons. And I've been told that it's inclined at an angle of 20 degrees to the horizontal. So let's draw that in like so. And that is a 20-degree angle there. So that force is going to have to be separated into horizontal and vertical components. I've got the horizontal one there, and the vertical one on there. That way. And let's just think about what other forces we have acting on this system. Well, we have the weight, which is 12G. We're going to have a normal reaction force, which I'm labelling as R. And we're going to have a frictional force. And the fact that the package is moving means that that's going to be at its maximum. We are also told that the package is accelerating. So I'm drawing an acceleration arrow here, and I'm given that the value of acceleration is 2 meters per second. So next thing I'm going to do is resolve this 50 Newton force into its horizontal and vertical components. So the horizontal component is going to be 50 cos 20, and vertical component is going to be 50 sine 20. Okay, that's all the forces considered, put into vertical and horizontal components. So now let's look at solving the problem. Now, we've been given that the acceleration is 2 meters per second. So the first thing I'm going to do with this one is resolve horizontally using that acceleration to find the value of friction. So here we go. So resolving horizontally using resultant force is equal to mass times by acceleration. My horizontal force here in the direction of motion is 50 cos 20. Minus my friction, which at the moment I don't know, is equal to the mass, which is 12, multiplied by the acceleration, which equals 2. So what I can do is I can rearrange that to say that the friction is going to be 50 cos 20 minus 24, which is 12 times 2. So I'll just pop that into the calculator, which comes out as 22.98. Okay, so that is the value of friction. So I'll just pop that on the diagram there, 22.98. Okay, next thing I'm going to do is resolve vertically to find a value for R. So looking at the vertical forces then, it's in equilibrium vertically because it's only moving horizontally. So the total forces up is going to equal the total forces down. So when I look to resolve vertically, I'm going to have R plus 50 sine 20, which is the vertical component, is equal to the weight, which is 12G. Now remember, in maths we use G is 9.8, so I'm going to do 12 lots of 9.8 minus 50 sine 20, which gives me a normal reaction force of 100.49, and then some extras. So I found friction, I found the normal reaction force. I'm now going to use the equation for friction, F equals mu R, to find the coefficient of friction. So I know that the friction is 22.98. I know that the normal reaction force is 100.49. I'm just getting my bits in between the storm units and interjections. So if I divide 22.98 by 100.49, I will get my value for mu, which to three significant figures comes out as 0.229. So there we go, that's how to find a coefficient of friction. Resolve horizontally to find friction, resolve vertically to find R,